assembly of programming NodeMCU using OTA. So here the only thing we need to do is to power our NodeMCU. Either we can use it using give the power using a battery, or you can use the USB cable. So the components we require is the NodeMCU, voltage regulator, 9V battery, battery snapper, breadboard, and the USB cable. So to power the NodeMCU using battery, we need to use the voltage regulator. First place the voltage regulator on the breadboard. Then take the battery snapper, connect the negative on the ground pin and the positive wire to the V-in pin of the voltage regulator. Then take a jumper wire, connect it to the V-out pin of the voltage regulator and then to the V-in pin of the NodeMCU. Then connect another wire to the ground pin of the voltage regulator and then to the ground pin of the NodeMCU. So we can power the NodeMCU by connecting the battery now. Either we can do it in this way or simply we can use the USB cable. Remove the wire, take the USB cable, connect it in this way and the other terminal to the laptop. So during the first part of the code, we need to connect the NodeMCU to the laptop in which the code is present. So we will upload it through the USB cable, and on the second part we will upload the code wirelessly. In that part we don't have to connect the NodeMCU to the laptop using a USB cable. Thank you. Coding for programming NodeMCU using OTA. First of all, open the Arduino IDE software. So this is the code for programming the NodeMCU using OTA. So first we have to include few libraries: the ESP8266 Wi-Fi library, the ESP8266 MDNS library, the library for Arduino Wi-Fi shell, and the library for Arduino OTA. Then we will declare our Wi-Fi name, username and Wi-Fi password and store them in the variable SSID and password. In the void setup, we will first initialize the baud rate, then we will set the Wi-Fi mode to station, and then we will initialize the Wi-Fi library, and then we will wait for the connection and restart our ESP. Then we are going to start the Arduino.OTA on start. This function checks the file type and initializes and starts the Arduino NodeMCU. So here we have created a variable type of string. So here we have given that if Arduino OTA.get command equal to flash. That means if the NodeMCU is getting a command from the serial monitor, it will make the NodeMCU compatible for the OTA, and in the type we will store the sketch. Otherwise it will store the file system. Then it will with the help of serial monitor we will display the current mode in the serial monitor. Then our Arduino OTA will stop. Then this is the function Arduino OTA.onProgress, and inside we have given unsigned in progress and in total variable, or you can say the input parameters. This will show the progress of the data received from the serial monitor. Then there is another function Arduino OTA on error that will highlight the type of error that will occur while the code flashes. So if there is error in the token, then it will say the auth fail. If it is error in the OTA begin, then it will show begin fail. Then if there is in connection error, it will say connection fail. If there is error in receiving the data, then it will say receive fail. Or if it is having some error in the AND, then it will say AND fail. Then we have given Arduino OTA.begin to begin the OTA, and then we have given serial.println function to display the IP address of the NodeMCU, and at the end we have used the Arduino.OTA.handle function. Thank you. After that, you upload the code. Click on Tools, select the board as NodeMCU 1.0 ESP8266 module and the required port, and then click on Upload. Your code will be uploaded to the NodeMCU. Coding for programming the new NodeMCU using OTA for LED blinking. So first of all, open the Arduino IDE software. So the code is similar to the previous one. The only difference is that here we are going to code for blinking the LED. So in the word setup, we have used the pin mode function to declare the LED as output. The LED here we are using is the built-in LED in the NodeMCU. Then the rest of the code is same. In the void loop, we have used the Arduino OTA.handle function, which gives the processing time for the Arduino OTA, and then we have used the digital write function to turn on our LED for an interval of 200 milliseconds and then turn off for another delay of 200 milliseconds. So after the code is uploaded, after the code is done, click on Tools. From the port, we have to select the ESP8266 port and then click on Upload. Programming NodeMCU using OTA. So first we will upload the basic code for creating the ESP8266 port. After we have uploaded the code, we can see if we click on Tools and click on Port, we can see that the ESP8266 port is created. Now click on this and upload the next code that for blinking the LED. I have powered my NodeMCU from a different PC laptop and my code is on this laptop. So I will upload my code wirelessly to this NodeMCU. So for uploading, select the port as the ESP8266. And then click on Upload. So it is uploading. As you can see, my NodeMCU, the LED on my NodeMCU has started blinking. If you see on the code, I have given a 200 millisecond delay to turn on and off my LED, and you can see the LED in my NodeMCU is blinking. Thank you.